Hey guys, hello everyone and welcome to the channel. So I am here with a question which could be one of the possible question that can be challenged in the CSIR net exam, and today is the last day to challenge the question, so I just thought to make this video so that I can inform you about this, right? So this is about a question ID 70118. Okay, that's the question from physical chemistry. It's a 4-marker question, and the question over here says that the rate of an acid catalyzed reaction in aqueous solution follows the rate equation given below. This is the equation given to you. The rate constant for this reaction at ionic strength 16 moles per liter and 9 moles per liter are K1 and K2 respectively. So what they are asking is the value of K1 log K1 upon K2 in the units of Debye-Huckel constant, which is B. Alright. So the question, or basically the idea is ki none of these options are correct. Okay, that's what I believe and what I have solved also, and I am getting the same thing. So let me first of all tell you, okay, that this question has been asked earlier. Okay, it's a previous year question, entirely same previous year question, which was asked in 2016 December exam. Okay, so let me show you. This is a question paper of CSIR net 2016. Okay, you have to do, you can download this is available on the CSIR net website. All you have to do is you have to come down to question number 138. Okay, so yeah, 138. Yes, this is the question. Now if you look upon the question, let me zoom this. So if you see the question now, it says that an acid rate of an acid catalyzed reaction in the aqueous solution follows the equation. This is the equation which is quite similar to that one. If K16 and K4 are the rate constant for the reactions at ionic strength 16 and 4 moles per liter respectively, ln K4 upon K16 in terms of Debye-Huckel constant is how much? Okay, that's what they are trying to ask. So let's try to solve this. Okay, let's try to first of all see the relationships, or basically the similarities in both the questions. So these are the two questions. If you look upon them, all right, it says that the rate of acid catalyzed reaction in the aqueous solution, rate of acid catalyzed reaction in the aqueous solution. This is from 2000. So this is from 2023 exam, and this is from 2016 exam. So everything is same if you look upon it. The only difference is that here the rate constants are 16 moles per liter, 16 moles per liter and 9 moles per liter, whereas over here it is given in 4 moles per liter. Okay, now let's see that how this question will be solved. Okay, we'll try to solve both of them and we'll see how basically you can solve these questions. Okay, so first I'll talk about this question. I hope you have a previous year solution or solution of previous year's question. Over there you can check out how this question has been already solved. Okay, so I'll just look upon, or I'll just show you that how that could be done. Okay, so let us look upon a reference first of all before going into the solution. So this is a book of chemical kinetics, 3rd edition by Keith J. Ledler, right? This book is very famous book, especially for kinetics. We generally call it Ledler, by chemical kinetics by Ledler. So that's the book which is being followed. You have to go to page number around 200. Okay, so around 200 you will get the reference of that. I'll just quickly go down so that. So here is the thing which you will find in around page number 197, 198, the influence of ionic strength. That's what is given over here. Now if you look upon what they have done is, if yeah, so they have used a equation used by Bronsted. Okay, so that's the equation which they have used, and based upon that they have tried to calculate for any ionic compound, let's say A, which has Z plus charge and B has Z minus charge. It is forming some constant and it is giving us a product. So the rate constant k can be calculated in this form. Okay, so it is said that the second order rate constant can be calculated with this, and then you can take the logarithmic of that to calculate it further, and then use the ionic strength formula to get it. Okay, so what we will get from here, so this is the reference which we are going to use to solve the question. Okay, now considering the same thing, let's look upon the question which we have. So considering the same thing, let's look upon the question that we are having. Okay. Okay, so to solve this question, what has to be taken first of all is, let's say if you have x plus reacting with y2 minus and in the presence of H plus ion, this is should give you a complex that is x y h, and that's the complex. The charge on the complex, it should be an uncharged species of course, and because the charges will be balanced, so that should give you product, right? Now looking upon the value of k, if you want to calculate the rate constant k, that should be equal to k naught and then the multiplication of your gamma values for all of them. So gamma of reactant, that is gamma x plus into gamma y2 minus into gamma h plus, and divided by the gamma value of this complex, that is x y h hash. Okay, so this should give us the value. Now if you calculate it taking logarithmic, okay, if I take log of it, so I have log k is equals to log k naught is equal and for these gamma values you can convert it in terms of like by converting it in the terms of ionic strength, right? You know that gamma is equals to minus b under root I and then the charges, right? Under root I and then the charge square of the charge, right? So if that is just one charge species, so it is like ZA square, like that. Okay, so we are using the same thing. So for that we will be having plus. When you are taking logarithmic, the numerators are going to be like or let's summarize it, or let's make the calculation much easier. We will be like taking it k upon k naught is equals to gamma x plus into gamma y2 minus into gamma h plus divided by gamma x y h hash. Okay, now if you take logarithmic, so this will be log k upon k naught, log k upon k naught, and this will be equal to yeah, this whole thing can be written in terms of, this is basically log gamma, right? So this can be written as log gamma x plus into plus log gamma y2 minus plus log gamma h plus minus, you will be having log gamma x y h hash, right? That's what you will be having. Now what you are going to do is convert in the this in the terms of ionic strength. So this is going to be log k upon k naught is equals to, the value of this will be written as minus b under root I, and the charge over here is plus 1, so plus 1 is square, plus for this will be again minus b under root I, the charge is minus 2, so minus 2 square, plus over here it will be again minus b under root I, the charge over here is plus 1 on the hydrogen ion, so plus 1 is square, and then plus the charge over here is 0, so that's why it will be minus b under root I, and the charge is 0, so 0 is square. Now if you substitute, or if you take this minus b under root I common from all of them, this is going to become 1 plus 4 from here, right? 2 square is 4, and then you will be having 1 square, that will be 1, and plus sorry, this should be minus, right? But it doesn't matter, but fine, this is minus, let's keep the sign as it is, so this is 0. So this whole thing should give you minus 6b under root I. That should be the value of log k upon k naught. Now since you are given with two different conditions, so let's do that. So we have a condition where log k upon k naught, let's say this is the first condition. for which I have minus b minus 6b under root I1. Okay, and I have one more condition, that log k upon k naught. Second condition is minus 6b under root I2. Okay, so I'll write down where I1 I will consider according to the question. Okay, so according to the question, the I1, the ionic strength is 16 and I2 is 9, and K1 correspond to I1, K2 correspond to I2. So this is 16 moles per liter and I2 is 9 moles per liter. If I, okay, let's keep this as equation 1 and 2. Let's just subtract these. So log K1 upon K naught minus log K2 upon K naught is equals to minus 6b will remain common under root I1 minus I2 under root I2, right? So you know log A minus log B is log A upon B. If you divide them, so this will become log K1 upon K naught divided by log K2 upon K naught. And on this side I will substitute the values, that will be under root 16 minus under root 9, and on this side if you solve, K naught will get cancel out, you will get log K1 upon K2, and on this side you will get minus 6b, under root 16 is 4, under root 9 is 3, so 4 minus 3 should give you 1. If you multiply 1 with it, so this should give you log K1 upon K2 is equals to minus 6b. This should come up as the correct answer for the question. If you look upon the options here, there is no 6b, right? The answer according to the key is minus 4b, right? This is according to the key. Now I don't know how this is being calculated. If you have the solution of this, you can see it is done in the same fashion, and the answer here was coming 12b, right? That was the answer coming up over here. You can try it off your own in the same way and you will get that answer. So in 2016 December exam this worked, but in 2023 this is not working out and we are not getting the answer which they have mentioned. Reference I have given you, I'll just give you once again, that Keith J. Ladler, okay, chemical kinetics. This is the book which we have, page number around 197 to 201. Okay, so I will also challenge this question. If you have any other way of solving it, or if you think that this calculation or the solution isn't correct, there is something wrong with it, please do let me know in the comment section. That will be very helpful for all of us, because this is where I am also stuck and I am also thinking in the same way. I would like to thank a lot of students, okay, for pointing out this and for sending me this whole thing. First of all, I would like to thank Avantika Das for informing me about it, and I would also like to thank Yashdeep for providing all the references and the calculation which needs to be done. Alright, so that's all for this video. Thank you so much for watching, guys, and thank you so much everyone for sharing your views. Please do let me know in the comment section if this question can be done in any other way which you guys know. Okay, so see you guys in the next one. Till then, have a great day. Bye bye, take care.